All right, so we're just recording this meet. And again, it's just so that I can put it on Classroom. I've done my hair, but okay, so we're just waiting for Grace to join us. There she is. And everyone's here. Okay. So today we're going to talk about function tables and rules. And we're going to also start we're also going to start talking about how to write linear equations from function tables. So with that said, here are some of the or some information that you need to know about function tables before we start. So, and we've already kind of looked at input, output, independent versus dependent variables. So this is kind of putting everything together. So X is our input value. It's what you plug into the function to get the output. X is also known as the independent variable. Y is the output value, and it's what results when you apply the rule or the function to the input. So it's kind of like our function machine when we were doing the Desmos, and the rule is like the machine, and then what goes into the machine is your input or your X, and what comes out of the machine is your Y or your output. When you put the input and the output together, you have an X and Y, right? So that's called an ordered pair. And you can actually graph it on a coordinate plane. So you can graph a function table. You can graph the function on a coordinate plane to see if it's a linear function or to see what type of function it is, or to see if it's a relation. In order for X, Y to be on the line, they actually have to make the rule true. So if you have a function table and you have a rule on the function table, in order for X and Y to be on the line, they have to follow the rules, right? So we already talked a little bit about the rate of change when we looked at like the taxi cab or the Lyft. Do you guys remember when we talked about Lyft and you guys figure out what the linear equation was? And we struggled with that a little bit. So today we're going to kind of break that down even further. So the rate of change or growth is found in a table by finding how much Y changes over how much X changes. So to find the rate of change or to find the slope, it's the change in Y over the change in X. You can also think about it like with each step, like from -4 to 0, what happened to Y? Well, if it went from -4 to 0, we added 4, right? That's change in Y. Is that adding 4? That's the change in Y. And then for X, the change in X was when we went from -1 to 0, is we added 1. So we have 4 over 1, right? So actually, I'm going to present my entire screen now because, so let me present my entire screen. Okay, so I'm going to, where's my snipping tool? Snip and sketch, where is it? There it is. All right, so if we're looking at this table here, in order to get from -4 to 0, we have to add 4. To get from 0 to 4, we add 4. And to get to from 4 to 8, we add 4. So each of these steps has a change of 4. So again, in order to find the rate of change, we have to look at change in Y over change in X. And lastly, when we're looking at the change, we're just looking at one step. So think of this as just one step. To go from one step to the other, what did you change? Well, I added 4, right? So I put 4. I added 4. And then from for x, the change in x is to get from -1 to 0, I added 1. So I'm just looking at one step, right? So it's 4/1. So my change in rate is 4, because 4/1 you can rewrite as 4. So ultimately, we want to write a linear equation like this, y equals mx plus b, where m is your change in y over change in x. Who can tell me what else this is? What is m? Is it your slope or is it your y-intercept? Who can tell me what m is? It's your slope. Very good. So m is your slope. And that's what this is. M is the change in y over the change in x. So if we just want to write our slope, we just have to figure out, okay, for one step, what's the change in y? And then what's the change in x for one step? We go back. The rate of change is 4. And this table is linear. This is a linear equation because the rate of change is the same. So each time it's a rate of change of 4/1 or 4, right? Because 4 divided by 1 is 4. So it's always going to change by 4. Okay. So what about this one? Is this linear or nonlinear? So in order for a function table to be linear, the rate of change has to be the same between each set of x and y values. So the rate of change has to be the same. So does this look like it's a linear function or a nonlinear?
It's a nonlinear.
Very good. It's nonlinear because in this table, the rate of change goes from 2/1 to 3/1. So it goes from 2 to 3, right? So if you see here, 2/1, and then it goes to 3/1, and that doesn't work. It has to be the same rate of change. What about this one? Is this a linear or nonlinear function? What do you guys think?
Nonlinear.
Well, why do you say that, Joshua?
Because as it goes over to -2, -2, and then goes to then goes -4.
All right, but if you look
Oh,
at
you add them, they will get to -4.
hold on, let me show you here. So remember, it's -2/1 is the first one. For this step here, it's again, it's -2/1, but then it's -4/2. So if you simplify each one of these, -2/1 is -2, -2/1 is -2, -4 divided by 2 is also -2. So as long as you can simplify it to be the same number, then it is a linear function. All right, so now you guys get to practice. Is this function linear or nonlinear? And don't guess. Try to see if you can figure out the steps. Like, try to do it out. Okay, so Caroline, you thought it was a linear function? So let's look at this one a little bit more. So in order to figure out if it's nonlinear or linear, we had to do, by the way, is Luke in here?
Yeah, he is.
Luke, you have to join our, did you go to join my quiz and enter this code?
Yeah. No, I hadn't went there yet, no.
Okay, I'm gonna put the link in the chat for the meet. You just gotta click that and then enter this number, 468351. And Luke, let me know when you're in. All right, well, Luke joined. I'm going to do this here. So that we need to figure out the change in y over the change in x to find whether or not the slope stays the same. So in order for it to be a linear function, the slope has to be the same. Like it has to equal the same number. So change in x. So for this one, 1 to 7, I had to add 6. And then from 7 to 3, I also had to add 6. And then from 13 to 18, though, I added 5. Okay, so then over here, we had -3 to -1, so I had to add 2. -1 to 1, right? I had to add 2 again. And 1 to 3, I added 2. So we had 6 over 2, 6 over 2, and 5 over 2. Right? So I had 3. I was off to a good start. They were following the rules. But this guy here did not follow the rules. So this is a nonlinear function. Good. Let's try another example. Is this function linear or nonlinear? All right, everyone got that. Very good. Nice. All right, now let's move on to writing the rest of our equation. So far, you guys have figured out how to write the m in the equation. But we have to write y equals mx plus b. So y is going to be your dependent variable, x is your independent, m is the rate of change, right? Or the change of y over change of x. And then the y-intercept is your b. So y-intercept just means when x is 0, y is whatever the y-intercept is. So for this one, you guys now know how to put the rate. You do 4 over 1, 4 over 1, 4 over 1. That means m is 4. So then how do we figure out b? Well, b is even easier to find. All b is you look for where x is 0. So where is x 0 in this case? At the top, right?
Top.
So x is 0. So then if x is 0, what is y? It's 3. Very good. So the way you figure out b, again, we're trying to write out y equals mx plus b. We know how to write our m. Now we're looking at how do we write our b, right? Oh, that's a horrible color. Hold on. Can't even see it. Maybe that one's better. Okay, how do we write our b? We just have to find where x is 0, right? And that's going to tell you what b is. So b is 3. Very easy, right? So b is 3. So when we're writing this out, the change over y and the change over the change of x is 4 over 1, right? So m equals 4 and b equals 3. That's all you need to know to write a linear equation, because you leave y and x, you leave those as variables, because throughout the what you're writing here is what the rule is. You're just writing the rule, right? So if we're going to write it, it's going to be y equals 4x plus 3. And 3 is our b, and m is 4. That's it. That's all you write. This is in y equals mx plus b form. You just have to write the slope, which is m, and your y-intercept, which is 3. Those are the only two things in a linear equation that stay the same. The y and the x change as you move from point to point, right? Like the y and the x in this point is 1 and 7, but the 4 and the 3 stay the same. It still changes by 4 over 1, and the starting point was still 3. Does that make sense? So the only things that you write when you're trying to figure out a rule, you just have to write the rate of change and your starting point. Your y and the x, you leave them as variables because those change as you move in the table. All right, let's move on to the next one. So for this one, you had to do the rate of change. It's 6 over 1, so that's m. And then your b, you have to find x. Where is x 0? Where is at the top?
And
So
this is also 0.
So then y is also 0. Very good. So the rule is y equals 6x plus 0. Or you can just write y equals 6x because plus 0, you can write it there. It won't be wrong if you write that, but you don't have to write it. Okay, so what about this one? We have our rate of change is going to be, remember, it's always the y over the x, right? The change of y over the change in x. So it's negative 9 over 3. And when you do negative 9 divided by 3, it gives you negative 3. So if you can, if you can reduce it, simplify it, you should simplify it. So negative 9 divided by 3 is negative 3. And then what is our y-intercept? What's our y-intercept? Our b. What is our b?
20.
20. Very good, because all you have to do to get your b is find where is x 0 and figure out what the y is. Yes.
I gotta go.
Oh, no. Okay. Bye.
Bye.
All right. For this one, same thing. Actually, this one is a little different. So let's look at it. Because sometimes they will trick you. So the first thing you do is you find, what the change is. To go from 0 to 3, it's plus 3. From 3 to 6, it's plus 3. From 6 to 10, it's plus 4. This is why it's important for you to actually do all the steps, just to make sure that you know what the rule is, right? And so then the y is from 2 to 8, you added 6. From 8 to 14, you added 6. And then from 14 to 22, you added 8. So if you write it, you have 6 over 3, 6 over 3, and then you have 8 over 4. So 6 divided by 3 is 2. 6 divided by 3 is 2. And then 8 divided by 4 is 2. So this is a linear function. So your m equals 2. Right? So when you're writing it, it's y equals 2x. And then what's my y-intercept? What's my b?
2.
So you have to write plus 2. Okay. This graph here is not linear because you have 3 over 1, 5 over 1, and then 7 over 1. So you can't write a linear equation for this because it's not linear. Okay. So now let's practice. Oh, no wonder it's not here anymore. I'm like, what? Who are we waiting on?
Oh, yeah. Forgot about that too.
Okay. So, all right, we're doing a good job here. Looks like, however, it does look like a few of us put 4x plus 3 instead of 3x plus 4. So you just have to be careful of that, okay?
I wrote my own notes to remember this,
Oh, very good.
and I do that for a lot, most of the stuff.
All right, let's try this one now. While you guys do this one, I'm actually going to sneak downstairs because my son is taking a nap. I'll be right back. Just gonna mute myself while I do it. And I'm back. All right, let's see. All right, let's see how you guys did on this one. All right, so 2 of us answered it correctly, and 2 of us wrote y equals 30x. So let's see. Let's do this one together. So you have to, before I think what's going on is you guys are looking at this number and attaching that as the m, but that's not where that number goes. You have to put it in the right spot. So the first thing you do is your change in y over change in x. So your change in y, to go from 30 to 28, you had to add 2. To go from 28 to 26, you had to add 2. 26 to, I'm sorry, subtract 2. Whoops. Subtract 2, and then from 26 to 24, subtract 2. So your change in y is 2, right? And then for this one, you added 1 to go from 2 to 3, add 1. So it's negative 2 over 1. That's going to be your m. So when we look at y equals mx plus b, your m is negative 2 over 1 or negative 2. So that's why you have to write y equals negative 2x. And then your y-intercept is where you're looking at the 0 x. So when x is 0, y equals 30. Okay, so sometimes, so for the x-intercept, I'm sorry, the y-intercept, sometimes they will not give you, it's like if you guys look at my screen, oops, no, that's not right. So sometimes they'll give you this information, and this looks tricky. First of all, let's do the rate of change. The rate of change for y, remember you have to make sure you're looking at the right area. So change in y over change in x. So your change in y is from 0 to 1 is +1, +1. It's +1 all the way through, right? So it's 1 over change in x is going to be +2, +2. So 1/2 is going to be your rate of change or your slope. So y equals 1/2 x. And now what's going to be our b? What's b? What's your y-intercept?
0, I mean, not 0, -1. Oh, we're talking about that. Yeah, 0.
So this is tricky because so this is +1, right? +1. To go this way, it's +1 change, right? And then this one, or +2, sorry. And to go this way, it was +1. So you need to get, for you to get your y-intercept, x has to be 0. But because we know that if you're going this way, you're adding 0, you just have to go backwards. So you have to go this way and subtract 2 to get to 0, because that if you subtract 2, you get to 0. Because you understand the rule now. And so then if you subtract 2, then from here you just need to subtract 1. So that's why you would get 0 over -1. So it would be 1/2 x minus 1. Okay? So let's try some practice.
How do we do it again? I'm lost.
So you have to find the rate of change first. So the change in y over the change in x. That's always the first step.
How do I usually go about that? Sorry, a lot of this kind of goes over my head.
So just the change in y over the change in x. Do that first. That's going to give you your m.